All right, we're back. We're back with more content. Trying to get back on the weekly schedule. Let's see if everything is up and running. Yeah, everything seems pretty good here. All right, so like the title says, checking out auto research. So yeah, thanks for watching, thanks for subbing. Seems like the last live I made was pretty successful, which is pretty encouraging. Even though the last live I made was more of a discussion type of live, it was nice to see a lot of views on the stream. We even got some comments, and well, one person commented that they wanted auto research out of the 3 ideas, and then I guess let's go down that path a bit. That's what I was thinking for today. But also, let's not jump right into coding, maybe. Because people seem to enjoy the more discussion type of streams. I want to do this more structured, so we also don't burn ourselves out, right? Because the other goal is to not burn ourselves out with a new series that becomes too complex too fast. So let's take it slow with the auto research, right? Let's see what it is first. So I want to spend today to recap for myself. I kind of know what it is, but then I was reading it and maybe I don't really know what it is. Although I think I know what it is. But yeah, let's check it out together and let's figure out what we'll do, because there is a chance here to maybe combine it with one of the other ideas. And yeah, I think the 3 ideas were, I didn't think of anything else, but they were either learning Rust from scratch for sort of back-end game development, learning Python, or Pygame, I think we found, or let me see, what did we end up finding here? Oh, PyScript it was, yeah, for sort of more of a front-end back development, game development, and auto research style AI agents. Okay, so we'll cover the basics of AI agents, high level. We can implement carpet these auto research. Let's say today's is not the first episode of the new series, right? So it's still sort of exploratory. But let me start looking into more detail at what would it mean to cover the basics of agents high level, and let's look a bit at the auto research framework. I'm not sure about the application though, so okay, so let's start looking into auto research. And AI agents. Very high level though. I'm not gonna go into details because there's probably a ton of resources out there today. So what is auto research? Well, okay, fine. What's an AI agent then? Should we draw it? Yeah, let's draw it, okay? So at a very, very high level, we kind of had this DSPy series, which were not AI agents. That was tightly controlled AI. It was like turn by turn AI, okay? So we were asking the AI to do something, then it was giving control back to us in the script, right? Just at a very high level, the agent is pretty similar, except so it starts from a prompt, okay? So, what's going on here? Font size is Oh, I know what's going on here. So this is way out of proportion, right? So let's say we have a agent prompt, okay, which says what do we want the agent to do, and describe the environment to the agent. That's pretty much all you need to build a successful agent, okay, at a high level. You need to tell the agent where they are. So we're gonna use this term environment, and you need to tell them two things: where they are and what do you want them to do. So let's make it more personable. What do you want the agent to do? Okay. So again, very high level, nothing too fancy. Now, let's see, do I have a background here? Oh, I see fill solid. Just messing around with colors. Yeah, this looks pretty good. Okay. So what is the... Let's put it this way. So it describes the environment. Describes the goal. Usually, or not usually, a single file, text-like file. Okay, so either .txt, .md for markdown, etc. Or, okay, so this prompt, this is the agent prompt somewhere. This is not the agent itself though, right? So the agent itself is another box that repeatedly interacts with the so-called environment. Okay, so the environment. And the agent. Okay, and obviously the agent prompt goes to the agent. Okay, because that kind of makes sense, because you need to give this prompt to the agent. And then the agent interacts by itself with the environment. Now the piece, what is an agent more exactly? Well, it's made out of, at the very least, an agent harness. Okay, so sometimes this is called scaffolding, orchestration. That's a bad name, don't use that name. It's called an agent scaffolding, a harness, an agent driver maybe. A framework. Okay, so an agent framework. There's no set name. Okay, for example, Claude Code is one. Okay, Codex from OpenAI, and etc. I don't even know what other popular ones are. There's many open source ones too, and it's made out of two things. And the second thing is a large language model. Okay. Or let's put it this way. API access to an LLM, okay? Let's make it even simpler. The ability to call an LLM. So we've seen this one. This second one is what DSPy does. Okay, so in DSPy, we did the call ourselves. Okay, so we were creating not the agent prompt, but the call prompt with a prompt. Okay, so be careful here because this is pretty much the only distinction, right? It doesn't say the ability to call an LLM with the agent prompt. It's just with a prompt, okay, decided by the harness, okay, through the harness. So what happens is when you give a prompt to an agent harness, it takes that prompt and it does things to it. In some ways, if you remember the DSPy series, that's kind of also true for DSPy because we just write the high-level signature and that's not really the prompt that goes to the LLM. It adds these sections to it. I don't know if we ever, well, I think we did look into that in some detail, but pretty much the agent harness is not that different these days, right? The only thing here is that this is much more autonomous, right? So we can draw a box like this, and we can put some color here. And this thing today is distant. Okay, so what is the environment then? The environment is a folder on a computer. It's only one thing. Let's put it this way. It's some I think the simplest way to say it is that it is a set of files on a computer. Okay? This is probably the most general way to say it. For example, a folder with documents, coding scripts in some language, okay? Etc. And maybe sometimes optional, the environment itself has another piece called internet access. Okay? So then what the agent does is the arrow here just means, interact with the environment. So modify the environment. So the arrow goes two ways, right? First it goes one way. The agent first does, let's draw it like two arrows then. So it's more satisfying, right? So the agent first modifies the environment, and then after it does a modification, get result back. Now remember, these are files, so the result can be the new file structure. It can be the result of querying a file. So for example, I don't know if modify is the right way though. query, maybe we should say. Yeah, maybe query is better. And then this goes on and on. Okay, let's see if we can draw a circle here. Maybe, kind of. Then we can take this thing. Okay, it's kind of... Well, we should have drawn it in reverse, right? So this just repeats it autonomously now. Hey, thanks for stopping. Doing good. How are you? Yeah, it's been a while. I kind of had to take a break after that marathon session, but I kind of decided to start a new series now. Maybe we'll start from more basics, and it's gonna be a lot more AI hype probably. But yeah, doing good. Yeah, I think we're pretty much done with that. I ended up submitting a paper. I should get the result in like 2 weeks, so I'll post it here on the channel. We'll see what happens. Today I want to look at the auto research stuff from Carpathy, and I was going through what an agent is, but very, very high level. All right, so then we had the agent that queries the environment and gets a result back, then queries again, that gets a new result back, until some sort of stopping criterion. And this is pretty much it. This is probably all the detail that we need. So again, the big part here is that you as a human, so human written and driven, okay? So you're gonna write the big agent prompt. Thanks. Yeah, we'll find out soon. I think the conference was a good fit because it was actually about reproducibility. Although we didn't quite, yeah, it was hard to reproduce. I had a lot of trouble in that weekend with the data distribution. It ended up not working out, but we'll see what happens. At least there were some sort of findings. So the agent prompt is human written, and then most of the loop is autonomous. Some harnesses will give you control back, okay? Like Claude Code will ask you before each query, do you want me to write that file? And that type of interaction also happens through natural language most of the time. I don't know, actually. Some harnesses may give you numerical options, like pick 1, or enter 1 if you want to continue, or enter 2 if you want to pause. So there is another brief moment for human interaction inside this loop, okay, between queries, or the agent may ask you to pick a type of query. But in any case, let's give a more concrete example now. I guess any type of file processing on a computer that you want an agent to do, that pretty much works from a prompt. So, examples of agents. Let's see what's happening here. So some examples of agents. A file editing and cleanup, or let's say a Word document grammar check agent, okay? So you want to tell an agent, again, you have to prompt it with the environment. So in this case, what is the environment? Environment, let's say it's a folder with many MS Word documents. And what is the goal you have to write in the prompt? You're going to write something like explore, open, read all MS Word documents in this folder and grammar check all of them. And that's it. Once you write this in a text file and you give it to Claude Code, it pretty much will work, okay? So the agent will sort of follow this goal. Now, the interesting thing is this is maybe not a goal, it's process, okay? You notice the way I wrote this goal, it's a very sequential goal. I could have only said grammar check all of the Word documents in this folder. So that's another way to, okay, so alternative goal, grammar check all MS Word documents in this folder. One is more prescriptive than the other. This one tells the agent more exactly what to do, and modern frameworks will obey, or they will try to obey, or let's say frameworks that use powerful LLMs, okay? Because it matters which LLM you use, because more powerful ones cost more. But yeah, this is basically an easy task for today's agents. Hang on, let's see. I mean, I have a question. Why don't you use this and see? I think it's just, I think I did that in the original paper. It's just the performance. Like, the performance is way better because you learn, the prior is much stronger with a learned UNet. Like, you actually get a chance to learn the distribution of a specific scenario. I think just a path distribution is, well, yeah, I'm not sure how to encode the specific delays there, because different distribution of channels, they have very, some of them have 2.3 nanosecond, a tap at 2.3 nanoseconds, then at 2.35, and they're all distributed around there. Unless you find a way to specify those in your framework, but then you also need to estimate those from data, but then you also don't know how many taps there are. That's the other problem. It all becomes meta, like without reading the spec, I don't think you can automate all that. I think the point with deep learning is to try to automate some of that just from raw data, like to actually learn the distribution. Okay, so let's see another agent. So let's pick something closer to home though. Example 1 of agent. Example 2 of agent. So something closer to home would be a Python code optimizer agent. Okay, so what's the environment? Well, it's gotta be like a Python, a folder containing a Python project. For example, like DiSco-MIMO, okay? So that's a fully self-contained folder that's pretty well defined and can be understood if somebody reads it, because hopefully we coded it clean enough. And what is the goal or the process that we want to tell the agent to do? So first we have to describe this environment, okay, which is not that hard for DiSco-MIMO. There's about 12 files in it. So I would just write a bit about each of them. Hey, you have this file that does that. You can run it like this. Then there's this other file that does that. You can run that like this. Then there's these other auxiliary files, etc., etc. So once we're done describing, okay, now what do I want you to do there? Well, optimize the hyperparameters, or so play with the hyperparameters in, let's say, train.py, such that training a model with uv train.py produces a score of at least 8. Okay, so play with or let's say, let me make this more generic. Modify the file train.py such that training a model with UV run produces a score of at least 8. This is one way to specify a goal. And now I made up the score of 8. This is kind of vague, assuming we described the environment properly, we should have described what the score is before. So that's pretty much, this is very close to what I want to do in auto research, because we'll have to end up describing to an agent what the environment is. And it's probably going to be something coding, right? Either DiSco-MIMO or maybe a Rust repository or a Py game or Py script or whatever we found. Doesn't matter. Yeah, so this is sort of a descriptive goal. Now I can write a more prescriptive goal here. I can write something like alternative goal. Modify the let's see. Modify line 37 in train.py such that running uv train.py uv run is at least 5% faster than the original code. Okay, this is another way to write the prompt. This is a more prescriptive one because now I tell the agent something a bit clearer. So yeah, I like to call this, let me highlight this. So goal process. So this is, whoops, no. How do I highlight this? Let's do it like this. And back. Okay, so these are the prompts I call okay. Oh yeah, there is some opacity I have here. Yes, I do have opacity. Well, I got this one I can't see now. Okay. And this one I need here. Sorry, what I was going for is that these are two distinct prompting styles. Let's make this one more consistent. We can say modify the code such that training a model produces a score of at least 8. Okay. So this is one way to specify the goal. The other way is to say something more specific. And here the order is flipped, right? This is something more specific. It's a more exact sequence of steps. Open, read all Microsoft Word documents and folders, and grammar check all of them. This one just says grammar check all MS Word documents. They seem kind of similar here, but they're not really because it's sort of missing the steps, open and read. It's probably more obvious. These two are much more closer than these two, but my point is that there are sort of two prompting styles here that I like to call a I like to call this one a descriptive prompt. Oh, let me see what's happening here. Okay, so this is a descriptive prompt. Let's be more specific. It's an agent prompt, okay? Because we don't know what the harness does inside. It does many things. And this is a bit one that's more detailed. It's a prescriptive agent prompt. Which one is better? We don't know. That's kind of the point. We're gonna have to play around. And we'll see. You can be even more prescriptive. Like, for example, I never said anything about the internet here. I could have been even more prescriptive. First, for example, for the second one, I could have said, first search the internet for resources on whatever this code does. Again, all this has to be written by hand. It's not magic. So the job of the human is to tell the agent what should be done as clearly as possible. Otherwise, stuff is just not going to work. And that's not good for anybody. And I kind of also described auto research, to be honest, here. We're pretty much very close to it. But let's actually check it out now. So it's auto research. And it's the case where the environment is code. Okay, so high level auto research is exactly this, but when the environment is code specific. Auto research is not made for Word documents or PowerPoint or whatever, although it doesn't matter. It's something very generic. Like, to be honest, it's one of the most generic things, and all it is giving an AI agent, or giving an agent some code that trains the model. This is why I brought up DiSco-MIMO, because we're basically there already. Okay, we have that code that trains the model. We did in the previous series. That's the entire DiSco-MIMO code, and it's not that complicated. Auto research is even simpler. Auto research just gives the model like one file that's a self-contained file, and tells an agent to modify it until the score gets lower. So in this case, lower is better. Okay, and the agent just gets to interact with this repo to edit the file, and then start the training run and get the result back. And this plot here shows this happening about, I don't know, 80 times, okay? And the score does get better. We don't know what this scale is. It's not relevant because we're not going to do this application. I guess it's 83 experiments and 15 kept improvements, okay? And that's it. So we don't really care what this code does. What we want to see here is we want to see how the agent prompt looks like. And we want to start thinking, how would we do it for an interesting series? So yeah, the repo is deliberately small and only really has 3 files that matter. This is actually a kind of a big hint, to be honest, for the YouTube series. Okay, so we can start from here. This is already a very heavy sentence, even though it doesn't seem like it. What this tells you is that when you start deploying agents on repos, it's better if they're simpler repos, okay? So again, this drawing is deceptively simple because it kind of makes it seem like, oh, you as a human just have to write the prompt and then you unleash the agent in the environment. That's not entirely true. You have to also prepare the environment for the agent. Okay, so the environment itself is also, and let's make this more generic, we can call this human designed. And this is true. I mean, unless you want stuff to not work and have to struggle with it, you'd better also design the environment for the agent before you even think about deploying an agent in some environment, right? You better know what that is and you have control over it. Okay, so this sort of closes the loop, because the only thing that's not human designed is the agent itself. Okay, so we're not going to reinvent Claude Code. That doesn't make any sense, obviously. We're not going to reinvent codecs. We're not going to go the DSPy way. Okay, so what DSPy is, it is something that can be used as a harness. It's a sort of an outdated harness. It has less in common with Claude Code, or in a way it has less, in a way it has a lot in common with Claude Code, codecs, etc. But it's sort of a different-ish harness. But we don't care about that. Okay, we're just gonna take a harness, probably Claude Code. We're gonna have to do two things though. We're gonna have to design an environment and an agent prompt. Now, if we do it on DiSco-MIMO, you may be tempted to say, we gotta be careful here too, because we may be tempted to say, oh, I have the repo. Okay, so I have DiSco-MIMO, which is, can I find this on GitHub public? I can, right? So I could drop an agent in here, okay? And it has a README that doesn't say anything. It has some UV stuff. It's not even 12 files, to be honest. It's 1, 2, 3, 4, 5, 6, 7 Python files. That's already a lot though. If you look at the original auto research repo, they kind of give you a hint here. It's only 3 files. So smaller is always easier and better, and it will make your life easier if you cut down as much as possible. So one goal would be, instead of rushing and deploying Claude, although again, these files are small enough that Claude Code will work with a, like a Claude Sonnet or whatever modern model, even the mid-size model. This code is only what? 150 lines. But the reality is we paid a lot of cost to get this code. That was the point of DiSco-MIMO, okay? It took us 33 episodes times, I don't know, 2 hours, about 60 hours of content and work to actually make this repo very small. None of these files is over what? These are very small files. And extremely small files now that I look at them. Like, none of these files is over 150 lines. Maybe the sampling is 250, fine. But they're very compact, very clean, and well organized, because that was the point of the DiSco-MIMO series. So that already sets us up for success. We have a very well organized small repo. Claude Code is probably going to work, but we can make it even smaller. We can help the agent have an environment that's perfect. And this is what auto research does. It's a very tiny example. Despite being so popular, it doesn't really do anything. That's kind of the point, is you want to give agents very concrete things. Okay, so it only has 3 files, a prepare file that should not even be modified. Okay, so when you describe this file to an agent, you're gonna tell it, don't modify this file, just read it or run something from it. And it has another Python file, which is actually, this is the only file, the single file the agent edits, train.py. We're very close there because we happen to call our training script, guess what? Also train.py. And this is a very human, natural thing to do, and this is gonna help the agent. If we had called our script banana, even the name matters, right? If I call this script banana.py, first, that's not clean coding. And second, I'm gonna make an agent's life harder because now I have to explain to an agent, hey, in this folder, there's a banana.py that actually does training. Now, again, modern models are powerful enough to just understand that and let's say, understand it as a fact and put it in their context, and retain it in their context, okay? Because it's a simple, concise fact. But still, why would you do that? You should not do stuff like that, okay? So we already have nice names for our code. We may need a bit more consolidation because this repo only has one script, which has a model, an optimizer, and a training loop. Now this sounds, again, awfully familiar to DiSco-MIMO, and this is basically the gist of any deep learning repository, right? You have a train that, guess what it does? It gets some data, it gets a model, an optimizer, and a training loop. What do you know it? When I wrote these, I mean, I knew, obviously these are just things, once you start writing a bit of deep learning, this is how you'll always structure your code. And it also has hyperparameters, which is exactly what, guess what, optimizer. Batch size, guess what, we already have a batch size here. Here they are. We have a batch size, number of steps, learning rate, epsilon for Adam. We have a noise schedule, which we tried to reproduce these from the paper. How do I know that the value 2315 is not better? We would like an agent to explore these automatically and run the training and get a result. And most importantly is, okay, so hang on, we'll get to it. We're missing a few pieces. Okay, so we're still in the stage of designing the environment, which, okay, the other part is baseline instructions for one agent. This is the prompt. Okay, so point your agent here and let it go. This file is edited and iterated on by a human. Okay, so in this repo, Karpathy forgot to say that the human is also responsible for the environment, which is a pretty big miss if you ask me, okay? Because it makes it seem like, oh, just use this recipe. All you have to do is to write the prompt, the program.md, for a repo, for your repo, and just point your agent here and let it go. I strongly disagree with that. I am the opinion that you should also clean up your environment a bit, okay? So make sure you have few files. Make sure you delete. That's why we did the clean coding series, right? I mean, it all fits together in some sense. Even though I didn't have auto research in mind at the time, and you know, more philosophically, maybe I shouldn't say this. I generally try to avoid saying too general things, but yeah, okay, we can leave this. But in any case, so the human is responsible for two things. Cleaning up the environment or setting up the environment so that it's very simple for the agent to understand, and writing a prompt file that describes the goal, the environment and the goal. Or the instruction, the prompt for the agent, okay? So let's plan what we want to do then. Let's start looking into auto research. Okay, so our goals, the humans. Well, we have to do two things. The things we just discussed, okay? Set up the first and foremost. Again, this is where I'm going to stray a bit from auto research, because auto research will have you and I know if you say it'll just work, I believe you, but that's not the point though. I want to convince you and teach you that you need to take care of your environment too. So the first and most important goal that we're going to do in the new series, will set up an agent environment that is clean, clear, clean, and concise. So we can call this the CCC principle, okay? So what do we mean by that? Clear, well-written code, starter code, good folder structure, okay? So not files scattered around in 57 folders or 3 levels of nesting or whatever. or let's say canonical, or how should you say this, idiomatic folder, or default folder structure, right? So whatever Python says to do online, that's how we're going to set up the repo, which again, we already did all this work. We did a ton of work in the DiSco-MIMO series. So check that out on YouTube if you haven't. DiSco-MIMO is not necessarily about the math behind, it's about how to organize the repo so that the advanced programmer understands it, and by extension, an agent understands it. Okay, so clear, clean. Well, let's see. Clear means default folder structure and file names. It also means good verbosity from scripts. Okay, so remember, when we run DiSco-MIMO, we see a nice print in the console that tells us how does our training run progress. So that's clarity. That gives you clarity into how the repo or the current experiment is doing, right? Without that, what would you do as a human? You would have to debug and breakpoint, or you have to edit the code so that it saves it to a log and then write another Python script that plots it, blah, blah. We don't need that. You see it in the console. So that's clarity, right? Seeing stuff in the terminal as training progresses, that gives you clarity and insight into the run. Clean. So this is where well-written, well-annotated code, okay? So good variable names, good modularity. Okay, so the code is split into functions, it's split into files. No, files are not too bloated, the imports are clear, etc. And then the third point is perhaps the one we did not work on and where we should improve. Before we unleash an agent on DiSco-MIMO, let's put it this way, concise. Okay, so no extra code, no useless code, no bloated code. So long story short, delete as much as you can from the repo. That's not a bad thing. I mean, no, obviously that's not a bad thing. You should know that. That's a good thing, right? So no extra files either. Don't leave files laying around. For example, here's an extra file we have. Today we have a README here, which is empty. If an agent sees this, or even if you as a human, if you say, oh, let me understand this repo. If we forgot to explain to the agent what the repo does in the prompt, and then the agent says, okay, first let me understand what it is. And then he opens the README and gets confused, it's empty. That's wasted time and wasted compute and wasted money by the agent and wasted context more generally, okay? It's a tiny waste, but you don't want that. So just either populate the README or delete it, okay? License file. Is this important for an agent? No, just delete it. That doesn't mean we delete it from GitHub where it's in public view, but before I give the agent this repo, I can just delete this file. And then you have to go inside each individual module and ask yourself for every, or maybe we'll do this. We'll ask ourselves, again, I don't know if I want to do this on this repo. Probably will end up doing it. So we may want to ask ourselves for every function. Do I really need all these numbers here? Can I cut some of them? Are some of them defaults? Do I need all this code? Maybe we can delete some, right? Although, again, we maybe took care of this. But here's one. For example, the whole data generation. If I want the agent to experiment with training, I'm just going to pre-generate data in a folder and I'm going to delete the data generation code completely, right? So CDL and data, they can just get wiped maybe. sampling can go. I just want to improve training. I don't want to improve sampling. I just want to improve training as measured by a training loss. So there's a lot of stuff we can clean up, okay? So this is my point being that, yeah, so I like to call these the 3 C's, okay? So then the second goal is what Karpathy says, to write a good prompt. Okay? Guess what? That is CCC again. Clear, clean, and concise. So what does this mean here? For what does it mean? Okay, so now we know what it means for an environment to be CCC, okay? Clear, clean, and concise. What does it mean for a prompt to be clear, clean, and concise? Now I'm gonna deviate probably a bit more from auto research. But these are my own preferences, right? So clear means prescriptive, not descriptive prompts. Okay? So don't tell the agent your goals. Tell the agent a sequence of steps to execute to achieve them. Okay? So this is what we had in the diagram. Instead of telling an agent, modify the code such that training a model produces a score, let's say improvement of at least 5%. Over the original code. I'm going to be a bit more, so this is the descriptive version. Now, okay, so let me do it this way. Modify lines 30 to 40 in train.py. Now, the prescriptive version is sort of focuses the work on what you actually want the agent to do. Now, there's a lot of expert knowledge here because this implies I need to know what lines 30 to 40 are. But let's just say that, I don't know, did I get them right? Maybe I actually got them right. Well, guess what? I actually got them right. So lines 30 to 40, well, the reason why I got them right is because I know these lines should be at the beginning. So again, it goes back to setting up the environment, okay? So a prompt and its environment are very, very closely tied. If you don't take care of the environment, your prompt, you will be forced to use a descriptive prompt, which I don't think is a good thing. Okay, I would prefer to have tight control of over the environment. Then I tell an agent, modify lines 30 to 40 in train.py. I also tell it exactly the file. This is in line with Karpathy's logic because he crunches everything down into a single file. We may be able to do that, but then I also like the modularity part. We'll see. We'll see how we design our environment, okay? If we end up doing MIMO, which we may. It's highly likely. And right, so I like to be more, so this to me is clarity, okay? So telling the agent a sequence of steps to execute to achieve. Don't describe the goal to an agent. Tell the agent, describe a sequence of steps, a sequence of concrete and specific steps to achieve it. Now, there is a double-edged sword here because everybody says like, oh, AI has, well, everybody's asking, AI may have a bit of creativity. It may extrapolate a bit from your goals and maybe this predict. So again, it all goes back to the agent loop. What does AI actually do? It queries the environment. Now, if I use a prescriptive prompt, the queries that I'm going to get from the AI will be around those lines, and they will be of the type uv run train.py. If I use a descriptive prompt, the queries may be different, and it may lead to new discoveries. So there is an argument that some people may say, oh, if you use too of a prescriptive prompt, you're sort of taking away the creativity of the agent. Nobody knows the answer. It doesn't really matter. I mean, it does matter for performance. I mean, the best thing to do is to try both, but there is a budget goal too. So maybe we'll stick with clarity and prescription instead of description. The other C now is clean. It's a well-written prompt, no grammar errors. Well organized in sections. So this is the same as good modularity, in the same way that our code is very well organized. The DiSco-MIMO code has split code into files. You want to split the agent prompt about the environment and the task into sections, right? And we'll see, Karpathy does that, okay? So he does the clean and conciseness part. And the last part is the third C, the conciseness. This is also obvious for an agent prompt. You don't want to ramble on, okay? So no extra phrases in the prompt. No unnecessary mentions of concepts. No prompt bloat. Okay, so don't start rambling in a prompt, which I actually think he has an example of a duplication in his prompt, which is not that good. He sort of says the same thing in 2 sections. That can be cut down. This is pretty important, I think. Depending on how the harness works, this may cost you a lot, because actually I don't know, to be honest, but I think Claude Code takes your prompt and appends it to every internal step, or what they call every tool call, or every environment query. So basically you have to end up paying real dollars. The longer your prompt is, you pay proportionately more in input tokens, which is not a good thing. So you can, and then you also have to wait longer. It's longer latency too, depending on how caching is set up, blah, blah, blah. So a shorter prompt is better, okay? Okay, so we went a bit. Now let's go back to the auto research. Now in his case, the code is a single file, which is good. He scores a very concise environment. It's also very clean code, and it's clear. Okay, so this is what I'm saying. Like, he doesn't really talk about this, but a lot of the work in this repo is setting it up in the first place so that all the code for training a large language model is about, it's 600 lines of code. And again, he has nice verbosity too. He prints some stuff. He prints a nice summary, right? So he prints what the loss is. This is the metric and how long it took and the peak VRAM. So then the agent can run this script once and observe it, and then change something in it and observe it again. Again, this is probably about exactly the same size as DiSco-MIMO, right? He also has a UV logpy project, which you need, I guess, because UV runs. He didn't pin versions like we did. Now let's look at his prompt. Okay, so his environment is clean. Now, of course, he has more stuff here, but I'm assuming he's gonna delete this notebook. The agent should not see this notebook. Yeah, I don't think so. Yeah, again, it's conciseness, right? In the environment, you don't want the agent to see all this stuff. So let's look at program.md. Now what he does is he also does meta prompting, because he prompts the agent harness. So he says the real prompt he gives the agent is not prompt MD, whatever is written in program MD, not prompt MD. It's actually, he gives a meta prompt. It says, hi, have a look at program.md and let's kick off a new experiment. Let's do the setup first. And then the harness So there is another choice here where I guess you can bake the agent prompt inside the environment, but we're not going to do that. We'll directly tell Claude the entire prompt. Maybe that's a mistake. We'll see. I don't have that much experience with Claude Code. Okay, now let's read the program.md. I guess this to me already seems wrong, okay? Because this first section is weird. The prompt starts with, this is an experiment to have the LLM do its own research. And when the agent reads this, it's very confused. Which LLM? Do what research? Because you mentioned two concepts here that you never talked about before. Like, this is the first thing the agent reads. It sort of biases the generation because these models are auto-regressive. So the order of concepts appearing in text may or may likely does matter. So there's a tiny mistake here. It should have started straight from setup. Okay, I would just delete this meta header here. The setup is more prescriptive though. Okay, so this is a good prompt because it says to set up a new, although again, he doesn't even define what an experiment is, which is very weird to me. It's not this. He should have said that the experiment is to train a model. This is what this should have been. This is, or he should have said the following steps describe an experiment that trains a model that trains a deep learning model. He's trying to be cheeky and meta here, but we can ditch this. Okay, so then the prompt is more prescriptive and well organized. So he has clarity and it's a clean prompt too. It's relatively well organized so far. So he has a setup section which tells the agent to set up a new experiment, work with the user too. Again, there's a weird phrase here, work with the user too. This implies it's not automated. Okay, we're gonna want to write our prompt that's fully automated. He tells the agent to propose a tag based on today's date, create a branch from current master. Master is deprecated on GitHub, it's main these days, so another inconsistency here. So he's lacking clarity or cleanliness, I guess. Read the in-scope files. The repo is small. Read these files for full context. readme.md, which describes what the code should do. Let's see what that looks like. There's a sort of, this is already a giant mistake because this readme does not describe what the core code does. This is a meta readme. But again, he's getting away with all this stuff because models these days are powerful enough to, these prompts are small enough and this repo size is small enough such that models are powerful enough they can just blast through all of this and understand your intent. But this is a very weird thing he did here, right? Because he says read readme.md, and when we go to readme.md, readme.md references program.md. And that's just not right. Like, this is as if I had a readme in DiSco-MIMO that started talking about meta things, okay? Instead of describing what this does, what the actual code does, it's as if I had written here stuff like, I don't even know, it's a mistake, right? Like, it's as if I had written here, in order to automate this repo, please look at auto research and do this and that and that. It's just not talking about what the code does. This is the real readme.md. Okay, so he should have started with this because these are clear steps that only talk about what the repo does. 4 steps, curl, blah, blah, blah. This is, again, a very meta thing because the agent will now, think about what happens here. There's a risk of infinite recursion because the agent sees readme.md and this tells it to spin up Claude. So then Claude code, which is the agent harness, will be tempted to spin up another agent harness inside of it that reads the same environment. When that Claude code instance reads this environment, again it'll read this line. It'll spin up another Claude code instance inside of it. So this is just a plain mistake, okay? So he doesn't have, what do we call them? He doesn't have cleanliness, conciseness, or clarity in the prompt here. Well, sorry, not in the prompt, I made a mistake. This is part of the repo, right? So the README of the repo is not clear, clean, or concise. This is why I put this setting up the environment as the most important thing we need to do first. First, we need a clean repo that has a good standalone README. Okay, this is a good prompt because this describes exactly what the files in the repo do. So there's prepare and train. This is also a good prompt. This is a prescriptive prompt. Check that cache, blah, blah, blah. I guess for some reason he delegates to the human here. I don't know if I like this part. Tell the human to run UV run. Initialize results, confirm and go. Good. This is also good. So this describes what the code does, right? So it says stuff like the training script runs for a fixed budget of time of 5 minutes. Now, again, he misses some things here to say that, again, this is why environment design is very important, because the human has to make sure this is true. Okay, so I'll bet you if we look in train.py, we'll find that hard limit. Okay, so we will find this. Let me move myself, actually. Can I move myself? Yes, I can move myself. Hang on, it's probably better. There we go. So it says the training script runs for a fixed time budget of 5 minutes. Well, who did that? Because the human did that when he wrote the environment. So if we look in train.py, let's see, can we find those 5 minutes? We're missing this. Our training script runs for, it's not measured in wall clock time. It's measured in steps. And if the model decides, oh, let me use a giant model. Okay, so sorry, if the agent says, let me improve DiSco-MIMO by changing the number of layers from 5 to 300. Unless we told the agent or we sort of enforced in the code the max number of layers, that's going to work, but training will take a long time and will burn our computer. What he does here is he goes with the real-time approach, which is a good thing to do. This is more generically speaking, this is a form of stricter verification because the agent can do less things to hack that. Unless the agent discovers quantum physics and speeds up time, there's probably a hard limit here. So if we look for time, there we go. So we have a T start time. And I'll bet you somewhere here. So the training loop is while true. T0 starts from, oh, here we go. T start training, okay? And he takes the time. And he measures how much time passed. There we go. And if the total training time is greater than the time budget, there's a break. So we're missing this logic today. We have a for loop, not the while loop and the break. So this is environment design, okay? This is only done for the agent because as a human, you don't really care if it's 5 or 10 minutes. I mean, as a human, you can also edit. The other thing is, how does he... See, he imports time budget from prepare. And time budget in prepare is 5 minutes. How do you know that the agent doesn't edit this file and cheat it? That's because, again, he did some environment work here where there's a nice comment that says fix do not modify. This is where we get into another topic that I may want to touch on in the series. This is not good enough, okay? So if you're a practitioner or if you want to deploy this at work, this is pretty gruesome because You're basically politely asking an agent not to modify things. There are better ways to do it, okay? And he should have done much better here. There are ways to immutably read, but we'll have to, maybe once we do the series, we'll talk about isolation and all that stuff. There is a way to define this as a universal constant that cannot be edited. Although I'm hoping maybe he has some check, or I guess he doesn't have checks. I don't know, maybe let's keep reading. Okay, so then he describes, okay, so if you're on train. Now again, he also reinforces this in the prompt. Okay, so first he reinforced the idea of not editing time in the environment, in the code. He also says it in the prompt. This is good. Double enforcement is good. Okay, so this is an example of aligning your prompt with the environment, which I generally am a big fan of. So it says you can modify train. This is the only file you edit. Everything is fair game. Okay. Again, this is not, I guess he is being half prescriptive here. By mentioning this list of things, you give the agent ideas, but then there's this vague etc here, etc., which sort of leaves it open. So I'm okay with this. What you cannot do, modify prepare.py. It is read only. It's the environment's job to ensure this. And I don't know if this is true, but this can be made true. So this is what I was talking about. In a Docker image, you can make this file uneditable, and then it becomes universal. But it doesn't, because the agent, okay, fine, so you import it from here, but then you do the comparison. So what if the agent decides to edit this line to say greater or equal to 2 times time budget? Because we just told the agent you can modify anything in train.py. So then the agent says, oh, let me increase my total training time by just editing this line to read 10 times time budget. So this is actually pretty sketchy. Now, again, for this code size, this is simple enough that Claude will obey, okay? That's not generally the case. There are better ways, and maybe we'll get to them. Maybe this is how we should start the series, with strict verification. We'll see how it goes. This is why I want to maybe not jump into DiSco-MIMO. Maybe do basic things, but strictly verify them. We'll see how it goes. Okay. You cannot install new packages or dependencies. Again, this has to be enforced, hopefully somehow. You cannot modify the evaluation harness. The evaluate BPB. This one is easier because you can make this file readable, immutable, readable but not writable. The goal is simple: get the lowest val BPB. Since the time budget is fixed, you don't need to worry about training time. Again, he's trying to reinforce some things in the prompt here, and just hoping that the agent doesn't modify the time budget. He's actually being a bit deceptive here, because he's not telling the agent not to modify. He's making it seem as some sort of superhuman entity or super environment entity will make this immutable. Then he gets into some more details. VRAM is a soft constraint. Some increase is acceptable. We'll probably have the same issues because we only have one GPU to run the train on. So the agent can run an experiment, but if he increases the model size too much, not only will it be slow, it may error out. But then, you know, that's fine. The agent should see the error, because we'll write the nice, again, we have our clarity, verbosity, right? So we want to write the training script that when it crashes, if it crashes, it prints in the console clearly that, hey, this was a crash because VRAM was exceeded, the neural network was too large, and then the agent will read that, and then the next step, he'll figure out to lower the size. Then he gives some hints. Simplicity is simpler is better. Small improvement that adds ugly complexity is not worth it. I agree with this. Conversely, removing something and getting equal. So yeah, again, see here, it's funny enough because here he touches on environment design too. He basically encourages the agent to simplify the code or simplify the environment he already finds. But the human can do a lot of this pre-work, right? The human can make sure that the initial code is simple. When evaluating whether to have change, blah, 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 the first run, your very first run should always establish baseline. Then it describes the environment once more, because once the script finishes, it prints a summary like this. Note that the script is configured to always stop. You can extract the key metric from the log file. I mean, this is simple enough. The agent can figure this out. This is a prescriptive prompt though, because I like this. It tells the agent exactly how to extract the val BPB. When an experiment is done, log its results TSV. Tab separated, not comma separated. Again, he did some bad environment design here. This should be enforced by the stuff like this means you are a lazy programmer, you did a bad environment, and now you have to beg the agent to not use commas for whatever weird reason. So just fix your environment and you can cut this sentence, right? You gain back from the prompt. The TSV, I don't know what this TSV is. I have no idea. It's some custom format. We're not going to do custom weird things because again, I guess it's a logging. I guess it's a basic database, right? With logging. Maybe it's fine. So he asks the agent to save a snapshot or, record a snapshot of the experiment here. The experiment runs on a dedicated branch, loop forever. Something weird is happening here because I don't know what he did here. He's repeating himself now. He already described train.py. He already said, so here is where his prompt is like, maybe he had an old version and he just forgot it here. All this stuff can be deleted because he already described this. He's basically saying the grep again, like here and here. I'm actually not sure what happened here, but there's a complete, this is what I noticed. There's this entire section is a duplicate of before the idea. And this is really bad. Like maybe this is the original prompt and it's obviously bad. It's not clear. It's not clean and it's not concise. It's just a wall of text that has no sections. It's not clean because it has some weird examples. User, why would you talk about sleep to an agent? It's all about code. Average human sleep. So this section he must have forgotten. But all in all, it's a short prompt. So this is all we need to do. And I don't see any difficulties. I think I like this, right? So we'll clean an environment. We'll write the prompt and then we'll use Claude Code. Now for the money part, okay, so then there's the third thing the human has to do. Pick a harness and pay for it. Now this is the non-trivial step because I have a GPU at home. I can run the DiSco-MIMO or whatever code we do on that GPU. I never ran a harness at home, okay? But I do have the Claude sub. So Claude code included with Claude Pro sub and decent limits. We'll need to use Claude. Maybe we can use Sonnet 4.6 at most. Maybe Haiku, okay? So unfortunately, I don't think we're gonna have enough budget to use. So I have a Claude Pro sub, which has been sitting there for nothing. So I have access to Claude Code and I do get some monthly credits. Now, again, remember the agent, what the human has to pay for. So human only has to pay for the harness, okay? Because I have a GPU. So this would be option 1. But if you have a GPU, there's an option 2, locally run a harness, which becomes a meta thing. I think we're not gonna do this, so let's cut this. How do we cut stuff in Markdown? Strike through. Oh, double tilde. Okay. Yeah, I don't think we're gonna do option 2. because then we only have a single GPU. So then if I run the agent model and I tell the agent to train a model on that GPU, I get less VRAM. The thing is, the only way we can use it, let's hang on, let me take this back. This means we can't run auto research on code that uses the GPU, because the GPU will be taken up by the agent harness itself, which is running a local LLM. So if we go down this path, so the easy way is to do it with Claude Code. It's more popular. It's going to be a better series. I'm really leaning towards that. But I also like open source stuff, and I like control, and I like explaining what the harness is. But maybe that's... So maybe these are not options. Maybe it's series 1 and series 2, okay? So once we successfully get it with Claude Code in a YouTube series, which should be very easy, it's just a cost thing. I just don't want to pay too much. That's the only problem. But once we get it, hang on, let me move myself back. Sorry. Okay, here I am. So once we get it going with Claude Code, we can then try the local version, which it's going to be a more detailed series because we'll have to understand what exactly is an agent harness. Like all this stuff like tool use, we're not talking about that now in this series. It's fine. So I think this is a good plan. So the agent environment now, what do we do in series 1? So the agent environment. It could be DiSco-MIMO. It could be starting from DiSco-MIMO. Okay. And cleaning it up. So when we say cleaning it up is minimize it. Okay, so work on the third C. Conciseness. I think that's the only part, conciseness. This is the only part that's missing from our repo. It can be shrunk even further. We can pre-generate the data. I think we can, yes. So we can mimic Karpathy's two-file approach. Okay, so train.py and evaluate.py. And set up true immutability for prepare.py and wall clock time constraints. I have some ideas. There are much better ways to do this than just importing from scratch. Again, it may not be necessary, but I think it'll be good content because it'll teach people this is how you should do it to really enforce a 5-minute, set up true time limits. Let's call them hard enforced because his is soft enforced. He doesn't really enforce the time limit, but there are ways where you can do this. The easiest is inside the Docker image. You can just make it abort a certain script. Oh, we'll have to learn that together. But I'm pretty sure it's very easy. This is just basic Linux stuff. So, okay. So, option 1. Starting from and cleaning it up. Option 2, what if we want to build an environment from scratch? It's not as easy as it sounds. Here is where I may combine it with one of the ideas I had last time. Okay, but hang on, let's talk about something else though. So, okay, so we clean it up. The critical thing for an environment is decide on a metric. For DiSco-MIMO, it's very easy because it can be validation loss after n minutes. Lower is better. So then the agent's job is complete. Okay, so now we know how to write the prompt. Let me put it this way. Sorry, we know how to fully write the prescriptive prompt because we can tell an agent, hey, check out this repo, check out these files. Your job is to lower the validation loss as much as possible. And this is a true meaningful thing because we can set up the evaluate.py. I'm going to call it evaluate, not prepare like Carpety does. We can set the file up so that it reports, for example, a generalization loss on MIMO channels, which is a good thing. That's a useful thing. So it's really auto research then, right? We are having an agent find the best architectures and hyperparameters that this is also publishable, to be honest. We may just do another paper stream, which is going to be pretty wild. Okay, now, if we go with option 2, a fresh environment. I was thinking to combine it with one of the other 2 ideas I had last time, and they were either Rust for backend So here's the thing, if we do the Rust thing, I first have to go through learning Rust. I really want to do the scientific backend computation in Rust, but I can't. It's going to be a whole series of its own. The meta thing to do is to have an agent write that for us and set up the environment. But we need a metric too. So the metric there would still be speed of computation. The thing is, when you have pairs of data so let's discuss a bit about environments, okay? So, types of environments. I'll classify them like this. With paired data, I know the inputs and I know the expected outputs from my environment. So then I prompt an agent in the style of modify the environment in any way as long as the input-output relation is correctly preserved. Okay? So, options for future content. Okay, so it's with paired data. Let me see how this looks in the thing here. Yeah, so what's happening here is the thing is we have to build, it's the human's job to build a paired database and enforce the checks. So this works for scientific computation pretty well in Rust, the first idea I had from last time. Because we can find some reference code and we can build a database out of it. So here's how I would do that. So I would do it developing the Rust scientific computation library with an agent. This is kind of like okay, so this here we'd have to implement a reference implementation in Python and get input-output data, set up an empty Rust crate for the agent, ask it to iterate on and write the Rust code that matches the pairs, e.g. measured by numerical accuracy. So we don't have to learn Rust for this. The trick that I'm doing here, okay, is because all I need to do is I need to write something in Python, and then I'm going to ask an agent to re-implement it in Rust. But I'm also going to give it an environment that measures how good the implementation is. And the agent will iterate, and that's auto research, right? Because now the only thing, this type of approach will start from an empty environment. Rust environment. So it's a different way than starting. Okay, the other type of environment is without paired data. Okay, so with paired data, but no starter environment. So, but empty starter environment. Okay. The other trade-off is I can start without paired data, but non-empty starter environment. I don't know the desired output because this is the case for DiSco-MIMO, okay? I do not know how much better the loss can be because this is a true research problem. So when we talk about auto research, it's always this type of environment, okay? Because the idea is to discover the data by yourself, okay? Or, sorry, have the agent discover the data for you, hence the name auto research, right? You don't know how low, even he didn't know here, he had no idea how low this loss could go. And this was the research in this case, right? Like the agent took it from here to here, which by the way is like a ridiculously tiny drop, I think. I mean, the scale is kind of whack. It's like second decimal improvement. It's the same for our DiSco-MIMO series. We know we can measure today what the validation loss is after 5 minutes. We don't know how low can we get it because we haven't done the research on the architecture, and that's what we want the agent to do. So then with this type of an environment is I prompt the agent in the style of modify the environment in any way as long as the metric is improved. But this one needs environment written constraints, e.g. wall clock time limit, which he has. Well, he doesn't really have, but that's what we'll do. So which one do we do? Do we start from a non-empty environment that we spent a bunch of time doing, aka DiSco-MIMO, and we just have the agent improve that? Or do we have the agent start from scratch, but we built a database of scientific computations and we have the agent write Rust? I think I'm gonna go with, I'm leaning towards option one. Rust is too much of a stretch, I think, because even though the agent may be successful according to some metric, we'll need to understand the Rust code and read it. And that's not gonna be easy for me. So then we need the Rust learning series, which we'll do maybe later in the year. For now, let's stick in Python world. Okay, so I think this is a good stopping point for a conclusion. I think we sort of learned a lot. We did. I hope you liked this. If you did, leave a comment or like or subscribe. Well, even if you didn't, just leave a comment, like, and subscribe. But the idea is, so let's recap, right? We went through very high level agents that start from the human has to do two things to set up an agent that improves something, aka auto research. He has to set up a prompt and an environment. These are in the wrong order. He has to set up an environment and a prompt. The environment is by far the most important piece. This is my opinion, okay? But fortunately, we did a lot of work here. We have the DiSco-MIMO environment, a set of files on the computer that does something. We're not going to do the internet access part. All we have to do is clean it up. Then we'll write the prompt that describes the goal for the agent. And we have a clear goal in DiSco-MIMO because it's very similar to Karpathy's auto research. It's literally training a model. Actually, it is almost exactly the same, just not by coincidence, because both him and I are deep learning researchers. So this is pretty much what we do. We write the training script that, well, it's more like I used to be a deep learning researcher, different story. But I'm pretty well versed in writing a script that trains a model by setting some parameters, setting an architecture, training on data, and stopping after a certain time, which is exactly what he did here. And he was able to get some menial improvement on whatever task. And then we have the environment, the agent prompt, and then we'll have to play around with Claude Code, which is apparently very easy. All we have to do is give it the prompt and the folder, and we'll just watch it work its magic. We'll have to figure out costs a bit. But I think this was useful, and I hope no coding, but I hope the thought process is useful and interesting. And yeah, let me know what you think if you have any opinions, but it seems like option 1 is the way to go. So I think it's a decently good stopping point today. So thanks for tuning in. If you stop by, thanks for watching. If you watch on YouTube, yeah, like, subscribe. I don't know if I'm going to cut videos from this. It seems the live was very successful, so just watch this whole live stream. Not that you would ever reach this point of me saying it without having watched it. Okay, thanks. I'll see you next time.